Alright, starting chapter 5.5.1 Trigonomic Identities. So I can identify and use basic trigonomic identities to find trigonomic values. I can use basic trigonomic identities to simplify and rewrite trigonomic expressions. So a couple of definitions. Identity. If the left side is equal to the right side, or all values of the variable for which both sides are defined. Trigonomic identities identifies identities that involve trigonomic functions. So these are some of the identities we're going to use. The reciprocal identity, we pretty much already know this, that like sine is the inverse of cosecant, and vice versa. Cosine is the inverse of secant. Tangent is the inverse of cotangent. Now, quotient identity, we know this too. Tangent theta equals sine over cosine, and cotangent theta equals cosine over sine. So this is two separate questions here. If cosecant theta equals 7 over 4, find sine theta. So the first thing we need to do is get our identity of what sine theta equals. So sine theta equals 1 over cosecant theta. So I'm just going to plug that in now. So sine theta equals 1 over 7 over 4. Remember, we reciprocate and multiply. So we're multiplying by 407. When we do that, we actually get sine theta equals 4 over 7. So you kind of already knew that. Here's one. If cotangent theta equals 2 over 5 radical 5 and sine theta equals radical 5 over 3, find cosine. So if we look back at our identities, cotangent equals cosine over sine. So we'll write that. Oh, I don't know what the heck happened there. Try that again. Cotangent theta equals cosine theta over sine theta. Now we're just going to plug in what we know. We know cotangent is 2 over 5 radical 5. We don't know cosine theta because that's what we're looking for. And sine theta equals radical 5 over 3. Okay, so just like any equation, I'm going to multiply by the denominator so I can get rid of them because that equals 1. Whatever I do to one side, I have to do the other. Now when I do that, I multiply fractions straight across, but I have a radical 5 and a radical 5 on top and bottom, so I can get rid of those. So I will be left with 2 times 1, which is 2, 3 times 5, which is 15. So cosine theta equals 15. So here I have, if secant theta equals 5 over 3, find cosine theta. So remember, cosine theta is going to equal 1 over secant theta. So we can just plug that in. So cosine theta equals 1 over 5 over 3. Remember, we reciprocate and multiply. So cosine theta equals 3 over 5. All right, this one's just a little bit more difficult, but let's talk about tangent. So first of all, we can always switch cosecant and secant back into sine and cosine. So tangent's going to be in terms of sine and cosine. So let's change cosecant into sine. So sine theta equals 1 over cosecant theta. And when I do that, remember we just reverse it. So sine theta equals 7 over 25. Cosine theta equals 1 over secant theta. So that means, once again, I'm just going to flip those. So that would be 24 over 25. Now, tangent theta equals sine over cosine. And I'm just getting this from my identities, cosine theta. So I'm going to take what I got for sine. I'm going to have 7 over 25. And I'm going to put that over what I got for cosine, which was 24 over 25. So here I reciprocate and multiply. So I'm multiplying by 25 over 24. I have a 25 on top and a 25 on bottom, so those cross out. Then I just multiply across. So tangent theta equals 7 over 24. Okay, we're going to look at Pythagorean identities. Sorry about that. Sine squared theta plus cosine squared theta equals 1. Tangent squared theta plus 1 equals secant squared theta. And cotangent squared theta plus 1 equals cosecant squared. So this is all, we're talking about this all on the unit circle. And if you remember, sine equals x, cosine, or sine equals y, cosine equals x. So when we change that, it goes to sine squared theta plus cosine squared theta equals 1. And then all the other trig identities are just modified from that. So if tangent theta equals -8 and sine is greater than 0, find sine theta and cosine theta. So if we use the trig identity that we just looked at, we are going to use the tangent squared theta plus 1 equals secant squared theta. So if I plug tangent in there, so that's -8 squared plus 1 equals secant squared theta. And then we're going to go ahead and square that. So we have 64 plus 1 equals secant squared theta. So 64, or 65, sorry, equals secant squared theta. So in order to get rid of that squared sign, we're going to do the square root. So it'll be plus or minus square root of 65 equals secant squared theta. And if we remember, secant is the inverse of cosine. So that means cosine theta equals 1 over the square root of 65. And that's still going to be plus or minus. Now, we know tangent theta equals sine theta over cosine theta. So we can plug in tangent. We have that. That's -8. Cosine theta, we just found that. It's plus or minus 1 over the square root of 65. And sine theta on top. So now we can solve just by multiplying. Remember, we're going to take 1 over the square root of 65, so those cross out. 1 over the square root of 65. So we have 8 square root of 65 equals sine theta. And it said sine was positive, so this will be a positive, which means cosine has to be negative. But, so we have sine, we found cosine, we said that has to be a negative, so we'll just write that down here. So it's going to be a negative 1 over radical 65 equals cosine theta. Okay, so if cosine theta equals 3/4, find secant theta. So we have to look at our identities, and cosine and secant, remember, are opposites. So secant theta equals 1 over cosine theta. So secant theta then is just going to equal the inverse of cosine. So it would be 4/3. If secant x equals 5/4 and tangent x equals 3/4, find sine x. So here, we're going to have to look at our identity sheet, and remember, we're going to have to change a couple things. So secant is the inverse of cosine, so cosine 8x is going to equal 4/5. Tangent x equals sine x over cosine x. So we have tangent, so that is 3/4 equals sine x over 4/5. Once again, I'm just going to multiply by 4/5 so I can get rid of that. I have a 4 in the top and a 4 in the bottom, so those cross out. So 3, ooh, I don't know what just happened there. Sorry, guys. 3/5 is going to equal sine x, and that's what I asked us for. Homework 285, 1 through 16 off. It is due Thursday, 3/2.